Hello everyone, this is Somendra from Tutela. I hope you are having a great time. Today we are going to do a topic which is fairly easy and is very scoring if you get it right. It doesn't take too much time to do the questions related to this topic. The name is sequences. Now, sequences in ACT and SAT are tested based on two types: arithmetic sequences and geometric sequences. So primarily we'll be talking about these two only. Now let's have a look at both of these. If you have a sequence in which you have a common difference, that means if you have a sequence, for example, I'll start a sequence with 2 and then I keep adding a constant to it, for example 5. So if I add 5 to 2, I'll get 7. If I again add 5, I'll get 12, and that's how this one keeps going. So this is a typical example of arithmetic sequence. Reason? You just have to move one constant up in order to move to the next term. So in arithmetic sequences, you have a first term, you have a common difference. But then the questions will require you to predict what term will be there at, say, 10th number, 20th number, or for example nth number. So I can see the terms here. At first number I have 2, second number I have 7, third is 12, fourth is 17. So in order to reach to a term at 10th place, what I'll do is I'll use this formula. I'll use the first number, I'll add a common difference 9 times. Now you must be thinking, in order to reach 10th term you should add the difference 10 times, but please understand the first term doesn't have a common difference on it, which means to reach to term 10 you will use this formula. This will result in 47. So I can safely say that the 10th term in this sequence will be 47. So the general formula that I can use for this thing is un will be equal to u1 plus n minus 1 times d, where u1 is first term, d is common difference, the difference between each term, and n is the place for the term. In arithmetic sequences, sometimes you also are required to find the sum of first n terms. For that also we have a neat formula. So sum of n terms will be n over 2 times first term plus the term at nth place. If you don't know the term at nth place, then what you can do is you can expand un formula from here. So if I expand that, you'll see that I'll get twice of u1 plus n minus 1 times d. Now that is a formula for sum of first n terms. Alright, so that's another formula from the video. Now I'll move on to the next type. Let me make a nice partition here. So geometric sequences, as opposed to the arithmetic sequences, have a common ratio instead of a common difference. So what I can say is, to reach to the next term, you keep on multiplying instead of adding or subtracting a common number. So I'll take an example. I'll start again with 2. For example, I want the common ratio to be say 3. So the next term will be 3 times 2, which is 6. Then I'll get 6 times 3, which is 18. Then I'll get 18 times 3, which is 54. That's how it keeps going. So again, I'll review it. I'll say that 2 times 3 gets you 6, times 3 gets you 18, times 3 gets you 54, and that's how you keep going between the terms. In here, the first term was 2, common difference was, sorry, it's not common difference. I just now told you it's going to be common ratio, so I'm going to represent it with R, and that's 3. So again, let's try to predict what will be the term at 10th place. For doing that, I'll choose the first number, I'll multiply it with 3, and I keep on doing that 9 times. That means 3 has to be multiplied 9 times. So I can say raised to power 9. Again, the same reason why I'm not using a 10 here is because the first term doesn't have a 3 multiplied to it. So that's how we keep going. So I can generalize a formula from here for the nth term at a place where we are talking about geometric sequence. It'll be u1 times r raised to power n minus 1. So that's another formula that we have. In here, the first term is u1. R is the common ratio, and n again is the place for the term. As we had a sum formula in arithmetic sequence, we also have a sum formula here, which is first term times r raised to power n minus 1 divided by r minus 1. Now this is fairly easy formula, there is nothing further to it, but then we have to understand one thing. This formula is applicable only if r is greater than 1. That means when you have a growing sequence. Okay. For other cases where r is a fraction, the formula will be Sn will be equal to u1. You just flip 1 and rn and you'll get the other formula, which is this. Now that's our sum formula for a GP when r is a fraction. You have a decreasing sequence. I hope you have understood everything till now. In order to make ourselves pretty acquainted to this topic, we have some questions here that we'll start solving. So the question number 1 says that in an arithmetic sequence, if the third term is 9 and 10th term is 23, which of the following represents the 20th term? So first thing to notice here is we are talking about arithmetic sequence and they are telling us that the third term is 9. I can write this as u3, which as per the formula will be u1 plus 3 minus 1 d, and this is given as 9. If I simplify it, I'll get u1 plus 2d equal to 9. Now that's our first piece of information from here. Now the question says that the 10th term is 23. So similarly, I can say that u10, which is going to be equal to u1 plus 9d, will be equal to 23. Now, if you look at these two equations here, we can solve them simultaneously and we can actually end up, say, subtracting 2 from 1. The result will be 2d minus 9d becomes equal to 9 minus 23, which gets us a minus 7d equals, it'll be negative 14, which gets us d as 2. If the d is 2, then putting this information in first equation, I'll get u1 will be equal to 9 minus 4, which becomes a 5. I have u1, I have a d. So in order to get to the 20th term, what I'll do is I'll use the formula again. U20 will be first term 5 plus 20 minus 1, which is 19, times d. Now that is going to be 5 plus 38, which becomes 43. Now that becomes our answer, so I can choose this answer. Let's move on to the next one, question number 2. Wow, this one's big, so I'll read it for you. There is a sequence of 4 numbers such that the first 3 numbers are in geometric progression and the last 3 are in arithmetic progression. Now that's tricky. With a common difference of 6. If the first and the last term are same, then the common ratio of the geometric progression is what? Alright, so first important thing to notice is we have got 4 terms. In order to solve it, I can just make 4 dashes so that I can put in the values. And then they are saying that first 3 are in GP, so these 3 are in GP, and the last 3, which are, say, I'll use a different color for this, and the last 3 are in AP, arithmetic progression, with a common difference of 6. Now that's where we can start solving this question. So the first term of arithmetic sequence, which is this, can be assumed as some variable, say a, which makes the next term a plus 6 because there is a common difference of 6. And then the last term will hence become a plus 12 because I have to add 6 more to the previous term. But then they are saying that the last and the first term are same. So I can safely say that the first term is also a plus 12. Now, I know that a plus 12 over a will get you the common ratio. Actually, it should be the other way around to make it easier for you. I can say that the next term divided by the previous term gets you the common ratio. So a over a plus 12 is equal to a plus 6 over a, since these terms are in GP. If I go on and solve it, cross multiplying, I'll get a squared equals a squared plus 18a plus 72. You can safely solve this on calculator. I'll solve it manually. So I'll get 18a equals negative 72, which gets me a equal to negative 72 over 18, which becomes a negative 4. So I got my first term of the arithmetic sequence, which is minus 4. That means the last term becomes a plus 12, which is negative 4 plus 12, which basically becomes 8. Now this is same as first term. In order to get the common ratio, I have a plus 12 and a. I can divide these two and I can get a negative 4 divided by 8. The result will be a negative half, which becomes the common ratio for the GP here. That was not hard, given that you have all the steps clear in your mind and you are good at concepts. Let's move on to question number 3. Question 3 says that which of the following represents a sum of infinite terms in the sequence? Now, this is pretty common in APs and GPs. They ask you something about infinite terms. So let us have a look at this kind of sequence. What is this talking about? I have a 4, then I have a 2, then I have a 1, then half, then 1/4, and so on. Let's try to understand. Is there a common difference? So 2 minus 4 is minus 2, and 1 minus 2 is minus 1. So no common difference. It's not an AP for sure. So let's try to see if it's a GP. So I know that 2 by 4 is same as 1 by 2. So this is a common ratio of half. So it's a GP for sure. So they are talking about sum of infinite terms. if I look at the sequence, what I'll see is I have a 4, then I have a 1, sorry, I have a 4, 2, 1 half, 1/4, and so on. First of all, in order to try and solve this question, obviously we have to see which kind of sequence is it. Uh, let's try to see if it is if it's an arithmetic sequence. For arithmetic sequence, it has to have a common difference. If I get 2 minus 4 done, I get a minus 2. If I get 1 minus 2 done, instead of a minus 2, I'm getting a minus 1. It's not arithmetic sequence for sure. Alright, so it's fine. We can move on and try some other thing. We can see if it's a GP. For that, the common ratio has to be same. So if I get 2 by 4, it's going to be 1 over 2, which is same as the third term over second term. So first term is going to be multiplied by a half in order to move on to the next one. So that's the common ratio. If you pay attention to the sequence, you'll see that it's the same common ratio that's keeping on moving to the next term. So it's a GP. So it's a GP. Now let us see how can we solve this question. They are asking about the infinite terms, but we didn't do anything related to infinite term. But important thing is they are asking about the sum. To find the sum, we have a formula written. So I'll show you the formula once again. If you look at the formula, these are the formulae for sum in GPs. But then I don't have this case, so I'm not going to use this. I'm going to use this formula because the ratio is a fraction this time in this question. The ratio is half. So let's write the formula here. I'll change the color for it. The formula is sum of n terms is first term times 1 minus r raised to power n divided by 1 minus r. For moving further, I want you people to be aware of a basic fact. Whenever a fraction, a number that lies between 0 to 1, is raised with an immensely big power, for example, if you look at this, for example, I just raise it with power of 5. I'll get the result as 1 over 32. If you go ahead and try and solve it, what you'll see is you'll get a very small number like 0.03125. That's already small. So just imagine how small the whole number goes if you raise it with power of infinity. It can safely converge to 0. With this knowledge in mind, we'll try and solve this question. So putting in values in this formula, I'll get sum of infinity terms equal to the first term, which is 4, times 1 minus a half raised with power of infinity, because I'm looking for the sum of infinite terms, divided by 1 minus half. Using this knowledge here, I can safely change the given expression to 4 times 1 minus 0, which is just 1, divided by 1 minus half, which is a half. Solving this further will get you the overall result as 8. Using this knowledge, we can deduce one more formula that I'll be writing here for you. For infinite terms, in this case, the sum formula can be written as sum of n terms equal to u1 divided by 1 minus r, because r n becomes 0. This is only if this condition is met, when r is a fraction. Now that we are done with one more kind of question, I have one last question that will give us a last kind of sequence that can take a lot of time if you don't know how to solve it. So let's have a look at this question now. Which of the following term represents the number at 15th place in the sequence? Now I don't have the answers here, So what I'll do is we can solve this directly and let us see what happens. I have a sequence and I have to find the term at 15th place here. So I'll have 1, 3, 9, 19, 33. Alright, let us see if I have a common difference. 1 to 3 there is a jump of 2. 3 to 9 there is a jump of 6 units. So clearly not a common difference. We'll abandon that idea. Let us see if it's a GP or not. 1 to 3 is times 3. 3 to 9 is again a times 3. Seems like it's a GP. 9 to 3 is not a 19, so definitely this one's not GP either. So which one is it? If this question is there in front of you in ACD exam, you don't have to worry too much. Just try and figure out some pattern. I was trying to find the sum. I was just seeing if I am just adding a 2 all the time or not. But then from second to third term, I'm adding a 6. Third to fourth, I'm adding a 10. And then I feel like I'm adding what? A 14. If you look at the differences here, you'll see that the differences are making an AP with a common difference of 5. Now that's where we can start cracking it. When the first difference of any sequence becomes an arithmetic sequence, you can call it a quadratic sequence. But then it just sounds harder. There is an easy way to get to the answer quickly. Now, if you pay attention here, the 15th term in the given sequence will be the result of sum of 14 terms here. Why? Because the first term in the given sequence doesn't have an AP term added to it. So in order to get the 15th term in the given sequence, we can get the sum of first 14 terms in the sequence that we have figured out using the first difference. So let's try to figure out the sum of first 14 terms. S14 will be equal to 14 over 2 times twice of first term plus n minus 1, which is 13, times d, which is 4. If you solve it, you'll get 7 times 4 plus 52. 7 times 56, which is, let me figure it out, it's 7 times 56, which is 392. S14, that means sum of first 14 terms is 392. Then 15th term in given sequence will be 392 plus first term, which is 393. Now that's how you'll get the final answer to the question that gives you a quadratic sequence. Alright folks, if you have understood everything from my video, please make sure to share it, like it, and hit the subscribe button. Hit the bell icon in order to keep track of the latest videos that we update. And goes without saying, if you have any doubt from the given questions or the concepts, you can make me aware of those in your comment section. Have a great day. Bye bye.